is, and then I'll probably just launch right into our next agenda item, which is kind of an overview of ASO data products, as well as our modeling products from the iSnobal model and our partners M3 Works as well. And then I'll hand it over to Dave Gotches to talk about our WRF-Hydro seasonal forecasting products as well. Because I didn't introduce myself before, Jeff Deems, co-founder of ASO, and unfortunately, Kate Birchinall had a conflict today. She's our project manager and typically part of the CASM planning team, but she sends her regrets today. And then also we're joined by, I think, a number of the M3 Works group who you'll get to meet shortly when they run through the iSnobal modeling. Okay, so our typical way of looking at the mountain snowpack is through what's really the backbone of our observational network, and that's SNOTEL and snow course data from the NRCS Snow Survey. This is from a couple days ago, but the picture's looking largely the same across the western U.S. Pretty good about around the middle and southern tier of the Intermountain and Continental zones, but a little dire up north. Zoom in on Colorado. A lot of green showing these days. This is I pulled these together for a presentation I gave last night in the Roaring Fork, so it's kind of Central Mountains focused, but the idea is the same. That really, as we zoom in, we start to see a little more variation in how the different watersheds stack up in terms of their percent of normal. But really, these data come from kind of a small set of stations. So it's really not the whole area of the watershed, but it's really this small set of stations that are producing these data. And there's a good bit of variation within those that is important. We zoom in on the Roaring Fork here, especially in the upper frying pan. We've got a bunch of stations that are right in close proximity to each other that are measuring somewhere between 98 and 143% of the 30-year median. So some significant variability even over those small scales, and certainly similar story at larger scales. What this highlights is that there's variability out there that we're not capturing through the station network. Even though they're providing a long-term record, which is key, they're providing a continuous in time record, which is super important. What they're missing, and no station network can really provide, is the spatial picture of where the snow is accumulating and how that spatial picture is changing over time. And that's because they're sampling a small portion of the overall domain. Here's just by looking at it by elevation, the western states and the distribution of SNOTEL sites by elevation in each state, with the maximum terrain elevation in each state is shown. And Colorado is the third column there, and you can see there's a good bit of terrain above and below the SNOTELs that we're just not sampling. And you can do the same thing by different terrain components. All of these are in flat forested clearings between 9 and 11,000 feet or so. So a key data set, but missing a good part of the picture, and that is the complexity that exists in our mountain snowpack. Here's an ASO snow depth image from a couple years ago, looking southerly into the Upper East River, town of Creston Butte near the top there. And you can see all kinds of different scales of variation in the snow depth from lower snow at lower elevations, higher snow depths at upper elevations, which is a pattern you might expect. But then all kinds of variation of wind and avalanches and other processes, sub-forest and above tree line. And really, in this basin, we're trying to capture the snowpack dynamics basin-wide with just 2 station locations. And that's a tough ask, even 10 station locations to struggle to do that. So what we really need is an additional data set to help capture the spatial component of the snowpack, in addition to the temporal component that is well handled over time by SNOTEL, and even longer in time by the snow course data sets. That's the motivation behind ASO. We started in 2012, really 2013 was our first snow season as a NASA jet propulsion laboratory project. After in partnership with NASA terrestrial hydrology funding, as well as state of California funds. And after about 8 years at JPL, we're getting the majority of our funding from operational entities, and has thereby exceeded NASA's science yearly mission. And we transitioned out to ASO Inc. in 2019, but continuing the same mission and the same priority, and that's to provide the two most critical snow properties to
Jeff, I'm going to interrupt you real quick. There is some audio issues coming in. I'm glad it wasn't just mine because my internet's been a little ridiculous lately. So if you want to maybe
transit.
Yeah.
Is that any better?
It's coming in a little clear. Give that a shot.
Okay. Sorry about that. Okay, are we back?
Yep.
So formerly as a NASA project was ASO providing the critical spatial properties that would allow us to improve our
Never mind, that didn't fix it.
Okay.
Maybe log off and log back on. I'm getting that same feedback.
All right, I'll be right back. I'll try a different browser.
It was fine when you were talking, Eric.
Sorry about that, folks. Good old technical difficulties. Yeah, Melissa, to answer your question, Jeff did try headphones and that didn't quite help. So it might be internet connection or needing to just log off and log back in. So hopefully we will see what happens. I guess while we're waiting for Jeff to log back in, I wanted to let you all know something I put in the chat as well, that if you have questions at all throughout today as we're moving through the different agenda items, please feel free to put them in the chat. We have our planning team online, like I said, so we should be able to answer questions that you may have via the chat. We can also, if we have time at the end, have some question and answer type of session. So just wanted to let you know that if at any point you have any questions, just pop them in the chat and we will get those answered for you.
How about now? That working?
Yeah.
Sounds better. Who'd have thought Google and Firefox are not friends? Okay, where was I here? Select. Sorry, everybody.
No worries. I appreciate you logging out and coming back in on a different browser.
Wow. I'm struggling to find the share thing.
Should be down in that bottom tray of tools, and I have you as a meeting co-host, so you should have the little square with the arrow next to the hand.
Oh, it's want permissions. Sorry, everyone.
This is Mark Robertson at M3 Works. I'll fill a little time. I don't feel too bad for Jeff because we always do Zoom with him, and that's the only time I'm on Zoom. So I'm lost when I share. So I'm taking just a small amount of pleasure in your pain, Jeff.
Why won't it show the screen? PowerPoint. is there. Wow, this is insane.
Jeff, if you want to maybe send your presentation my way and I can.
I'll try this one more time.
All right.
Back.
Well, again, while we're waiting for Jeff, one thing that I would like to kind of reiterate about this program, we're not looking to replace NRCS SNOTEL. That is not anything that this program is intending to do. That's not something that ASO is intending to do. This extra high-resolution snow data is really meant to be complementary to and help really enhance the stream flow forecasting. So we're not looking to replace NRCS SNOTEL. It will always be the backbone of snow data and stream forecasting. So I just wanted to make that clear as well. This is not going to be a replacement at all. And I see Jeff's slide is up.
And am I audio capable?
Coming in loud and clear. Excellent.
Goodness. Okay, I get an F for video meeting management today. Okay, try to pick up my flow here. We are mapping snow depth with a LiDAR and snow albedo or reflectivity with spectrometer. We work with M3 Works and the iSnobal model to model the density of the snowpack times the depth to get water equivalent. In that density modeling, we use, as Eric was just mentioning, we put the SNOTEL and snow course data to work to constrain that model. So we actually absolutely depend on those data sets. We just put them to work in a different way than using them in an index fashion for forecasting. We do all of this with an expedited timeline. We fly high, we fly fast, and we turn products around quickly to make them most useful for decision support. So I'll run through some of our data production and data products and hand it off to M3 Works and Dave Gotchis at the appropriate times here to talk about those components. So here's our overall workflow. Again, we fly a LiDAR spectrometer and a camera at high elevations, and we try to fly the entire watersheds in one flight or in short order to capture that full basin effectively and efficiently. When the plane lands, we run the hard drives across the street to where we have an upload location, push everything up to the cloud, and run through some pretty intensive processing steps, turning a terabyte or so of raw data into multiple terabytes of data products in short order, and producing a set of primary products, which I'll go into in a moment. We hand those off to our modeling crews. There's actually kind of a cyclic iteration with the M3 Works group to get the snow density as a part of the primary processing sequence. And then this actually is an out-of-date slide. That NCAR logo there in the center was where Dave used to work. And we would hand data off to him to get into the WRF-Hydro model there. He's now doing that in-house with us, and he can describe more of that effort. We also work with other forecasting agencies, including the California Department of Water Resources in their Bulletin 120 forecast process, with the Colorado Basin and California Nevada River Forecast Centers, who have been producing experimental forecasts with our data, as well as a number of other forecast modeling efforts that our different stakeholder partners run independently. So a little bit more about our flight patterns. The way we fly is a little bit atypical for geospatial and LiDAR surveys. We fly at a consistent and high altitude that gives us a homogeneous and watershed spanning flight pattern. We integrate both the LiDAR pattern and the spectrometer pattern into the flight planning to give us consistent coverage. And all of this gives us collection efficiency to hit narrow weather windows and ensures homogeneous accuracy of the data products and allows us to be, as I said, weather nimble to hit those narrow windows. So once we conduct the flight in the sort of mowing the lawn pattern, like illustrated in the top left here, to get full basin coverage efficiently. We then do our initial processing to turn the LiDAR into point clouds of elevation. We do some homogenization steps to make sure that all the data agrees with each other and to make sure that we're getting the terrain efficiently, and also some primary level spectrometer processing that helps us classify the terrain into snow covered and not snow covered. Then we do an important step, and this is really the step that ensures our basin-wide accuracy of the snow depth retrieval. We take our snow surface elevation map and the snow-free elevation map that we've collected previously, and we snap those together in areas where the spectrometer tells us that it is snow-free. And that basically gives us control points throughout the basin at all elevations, all parts of the domain. And we can bias correct one of the two grids such that when we perform the subtraction of the two elevation data sets, we get 0 snow depth where the spectrometer tells us there's no snow. That does two things. One is it enforces the accuracy of that depth calculation throughout the whole domain, not just enforced by a couple of data points or locations. And it also gives us a quantification of the uncertainty, because we can look at all those areas where we know there's no snow and see exactly what the subtraction is telling us. And it will be, a mean of 0 plus or minus a centimeter or two typically. So that gives us a quantification of the uncertainty in the depth retrieval throughout the domain. We then work with the density model, and this is where we push the snow depth measurements into the iSnobal model. We get the density back from the model, and we do some bias correction on the densities as necessary, guided by in situ SNOTEL, other snow pillows, snow course, or other manual data sets that exist or are conducted in concert with the flights. That then also helps us maximize the accuracy there and also informs our basin-wide SWE uncertainty. And then we get to that full basin SWE inventory that captures the spatial variability and is tied to the station network. So it really ultimately is a fusion of the spatial products from the ASO surveys and the temporally continuous products from NRCS SNOTEL and California Snow Surveys snow pillows. Our primary data products that we put out are all available on our website at data.airbornesnowobservatories.com. When they're available, we send out an email report delivery to all the stakeholders involved in each basin, and attached to that report, the data announcement, and attached to that announcement is the report for each survey. Some screenshots of that on the right here, and these reports give sort of a graphical overview of what the data look like, some subdivisions into different sub-watersheds that have been identified in concert with relevant stakeholders, and then some other tabular and text descriptions of the production and the evaluation of each data set. So a ton of information in those reports. We produce a couple of text distillations of the water equivalent maps as well. I'll show those on the next slide. And then the maps we produce are 3-meter resolution snow depth, 50-meter resolution water equivalent, 50-meter albedo, and then all of these are packaged together and downloadable from the website. A few more things that come out of the report. Here's some of the graphical summaries. Example from the May 28th flight in the Roaring Fork last year. So elevation distributions of water equivalent, like in the center there, an overview map, the Radial plots on the bottom show the distribution of snow water equivalent volume, in this case, by aspect and elevation, and the change in that between flights if it's a second or later flight of the season. And then the table at the top you can see is the total area snow water equivalent and uncertainty estimates, and then subdivision or breakouts of that total into the subbasins. Here's what the tabular or the text products look like. Some summary statistics of the snow water equivalent map, and then an elevational breakdown of SWE, snow covered area, etc. Here's what the snow depth map can look like, really highlighting the variability that's out there, and multiple ones over time. Additionally, the albedo products, especially in Colorado, can be really important, capturing both the natural aging and coarsening and darkening of the snowpack in the near infrared due to grain size change, and then in the visible, primarily due to the presence of impurities like dust on snow. This is the April 12th and 28 flights in the Roaring Fork last year. The picture on the left is the base of Buttermilk ski area the day after the gnarly dust event on April 3rd. So the ability to capture that and then have that quantification of the snow surface albedo available to stick into the models can really help constrain them such that the melt rate proceeds at the right pace. All right, I will hand it off to M3 Works crew. Mark, I heard you on. Is that your cue?
That's me. Thanks, Jeff. And actually, I kind of tricked you, I guess. What I didn't say was if I had been doing the slides, I also would have probably gotten hung up. So I just made you take the brunt of it there. So no, really, thank you. Hello to everybody. My name is Mark Robertson. I'm with M3 Works, along with Micah Sandusky, Kahan Yang, and Micah Johnson. A couple of us there. We've been working with ASO for a number of years, as Jeff mentioned. So we do the physically based modeling component of this program. And so I'll try to be brief, pretty fast overview. Feel free to reach out to me or any of us with other questions along the way, though. So as Jeff mentioned, really the backbone of this project is the combination of the measured snow depths with modeled iSnobal snow density. We'd love to be able to measure density across space and time, but that's not feasible at this point. So we model it. Doing this, we replace the largest source of uncertainty in basin-wide SWE, which is snow depth, with direct measurement. And the figure on the time series figure here is just a schematic idea of what we're trying to get at. So there's a fair amount of uncertainty in the modeling component, represented by that shaded area there. I think this is the Tuolumne Basin from last year, 4 million acre feet up there. So at the points of ASO flights, we drastically reduce that uncertainty. So that's what we're after with the project. A little bit about iSnobal briefly again. Well, we drive the model with input from NOAA's high resolution rapid refresh model. We downscale that to a 50-meter resolution, and then we update along the way the snow depth model state with measured state from ASO, same with albedo, and we bias correct the snow density. And you can move ahead there, Jeff. A little bit more about iSnobal itself. It's a physically based energy balance snowpack model, so it solves energy and mass fluxes to create the model snowpack. It's a 2-layer model. The 2 layers do not correspond to any physical snowpack layering. They correspond to how we handle the energetics between the snow in the atmosphere and the snow on the ground. And really crucially here, it was designed to incorporate remote sensing products. And that's a tip of the cap to Danny Marks, who wrote it, but you can replace model states such as snow depth and albedo seamlessly in this. So that's a very important component. Okay. Real briefly here, we do downscale the model inputs from NOAA's HER, which is a 3-kilometer product. We downscale that to 50 meters using inverse distance weighting. The wind is handled a little bit differently. We use a different product to do that and downscale first from 3 kilometers to 200 meters. You can move ahead, Jeff. So again, folks are most familiar with this, right? We combine measured snow depths with model snow density. This is just a GIF here of replacing those snow depths in the Merced Basin in California. I won't linger too long here. Jeff, you can advance. I think we're familiar with this, but what is really exciting is that we're beginning, all of us, ASO and M3, are beginning to realize the power of iSnobal here as a way to time series connect all of the remote measurements that ASO is making. So it's really a time series connection of measurements is how we're viewing it now. So that's not only snow depth, but albedo, which is absolutely crucial in the melt season to get snowpack melt and timing right. And you know, the model albedo, those products are tough to get. Real-time albedo products are tough to get, and they're crucial in getting the melt states and the energy states correct. We also use ASO measured vegetation height as static input to our model. And that's also crucial for getting the energy balance correct. We can also incorporate and use other products, snow covered area, and so on. Go ahead, Jeff. So a little taste, if you've seen the reports from ASO and us from just model update reports from M3, you're probably somewhat familiar with this. But we do have all of the snowpack state variables output on a daily time step. So, you know, SWE, snow depth, snow density, all that, snow temperature, all that kind of thing. We also output surface water inputs daily. And that surface water inputs, we call them SWI. That's the combination of rain and snowmelt on the ground surface. So it's all water inputs to the ground surface. This figure here is the time series figure on the right is from the Blue River in water year 23. The vertical red lines are where we updated the depth state with ASO measurements. We also have cold content, which is a measure of how much energy is available or needed, to bring the snowpack to isothermal or 0 degrees C. That's an important component when we're looking at things like potential rain on snow events, flooding, things like that. We have, again, SWE maps available both spatially and histograms of that. And you can advance, Jeff. I also want to echo what several folks have said. The station measurement network, so NRCS across most of the state, but also in California's program, that station measurements are just absolutely crucial to our work. And there's no replacing any of that. Here we've got some validation of snow tells in the Blue River Basin compared to model values at those pixels that contain the point that the station is in. And this is really the only way we know how to guide the model without having ASO measurements, which are obviously not every day. We do not drive the model with SNOTEL measurements. We use it as validation and use it to bias correct those fields. So obviously another component of model validation is the ASO surveys themselves. That's obvious. We can also use snow covered area. It's a little hard to see. That upper right figure is scale is probably a little too small to see, but we can shade where snow covered area is from various products and the model snow covered area. We can also do snow course comparisons. And that is quick overview of M3 Works and the physically based modeling component. And back to you, Jeff.
Awesome. Thank you, Mark. I think I'll hand it off to Dave Gotchis here now to talk about the WRF-Hydro, and then maybe we'll entertain any questions on the ASO and M3 and WRF-Hydro components after he's done.
Great, thanks. You mind driving, Jeff?
Sure.
Okay. So yeah, we've been at the WRF-Hydro modeling for seasonal water supply forecasting in Colorado now for getting close to 9 years. I think this will be our 9th year. We started in 2015-16 down in the Rio and the Conejos, working under some funding from CWCB, and been fortunate enough to just see a nice expansion of the work here in Colorado, and then the last few years also in California. And so we've been evolving the WRF-Hydro model, starting with some configurations that the model's used in operations as the national water model run by NOAA, but then making a lot of special adjustments to the model for the kind of work that we're doing for seasonal water supply forecasting, and starting to perform a lot of the assimilation similar to what Mark just described. So for those who are not familiar with the WRF-Hydro model, this is a very sort of general, high-level schematic. The model runs on a variety of different spatial frameworks, some being grid, some being catchments, and a vectorized river network. We have full energy balance and water balance conservation in the model. Essentially, it's running across the landscape. It's moving water down gradient, excuse me, across terrain gradients and into channel networks, and then flowing that water downstream through a highly distributed channel network. And of course, it's handling a lot of the spatially distributed physics, snowpack, infiltration, evapotranspiration, sublimation, so on and so forth. Certainly a lot more could be said about that. I kind of want to jump over and pivot to what the process looks like and what the products look like that are starting to come out of this. And so I'm doing this in the way of a status update here. So we've been running this version of WRF-Hydro for the last couple of years, which was equivalent to a version 2.1 configuration of the National Water Model. And then we subset out from that domain for these regional domains where ASO is conducting operations. Over the past year, we updated to a new version of WRF-Hydro. It includes some of the new functions that are in the latest version of the National Water Model. You'll see a lot of things like new infiltration scheme, updated parameter adjustments for land cover and land type. We've updated albedo parameters based on some research in a paper led by Ronnie Abalafia Rosenzweig from NCAR and some other folks. Mackenzie Skiles was on that. Coming up with some ways to better optimize our albedo decay curves for the Colorado region. We've updated the calibration of the model that we use for our seasonal water supply forecasting here, and also done some updating of the real-time precipitation foreseen, moving away from the traditional INLDAS data, which has suffered some, I think, just some general decay and degradation in its operations, and moved over to a new bias adjustment of HER, which brings us a little more in line with what Mark and the iSnobal folks are doing with some of their meteorological forcing. So we're trying to get some synergy going with that. Probably the other major thing that impacts the ASO assimilation work for this year is how we're updating some of the regridding and upscaling of the ASO data to the WRF-Hydro model grid. And this is an important thing for folks to keep in mind. As Mark and Jeff have mentioned, the ASO products are coming out at 50 meters. We're running the WRF-Hydro model across a large domain, which you'll see here in a bit, with a 1 kilometer resolution. So that's a pretty significant upscaling. And our work in prior years saw some significant interpolation artifacts, particularly at some of those really nice and critical high elevation, deep snowpack areas. And so we've come up with some statistical weighting to adjust for some of the errors in those interpolations at that area so that we're better conserving the total mass of SWE during that process. So that's a nice addition we're seeing this year. We've completely updated our reporting with a lot of new monitoring and forecast products. I'll show several of those here in a minute. These include some of the probabilistic flow forecast graphs, in addition to those traditional spaghetti plots, which I know everybody loved to try to figure out. We've got a lot of information on seasonal snowmelt, albedo projections, snowpack temperature analyses, and we're also starting to include evapotranspiration fluxes. And we're putting out a number of these different products, not just as a forecast of what WRF-Hydro is saying the world could be like, but if people are looking for other sources of information for their own water balance modeling, there might be some opportunities for some interactions and some collaboration there, particularly along the lines of those evapotranspiration forecasts. And then in Colorado now, we're going to be including a new set of basins in addition to what was done over some of the past years to include the Yampa and the Elk system in Northwest Colorado through some local funding from those folks in the basin. So that's going to be an exciting new area that we'll be forecasting in. Next slide, please. So generally, this is our overall model domain. Here's a number of the different basins that we've been working in. A couple of these have dropped off due to just shifts in fundings and things like that. But in general, this is still the primary picture that we're seeing for the basins that are being forecasted in. We actually have a continuous model domain, even though there's a number of different basins where there is actual forecast products being delivered. You can see the total extent of the model domain in the upper right-hand inset diagram. That plot you see is of integrated model soil moisture or soil saturation, which is another variable that we keep track of and report on in all of our reports so that folks have an idea of, relatively speaking, how saturated their basins are and what is some of the residual water holding capacity that still remains, particularly heading into the melt season. Next slide. So now we're going to look at a bit of the forecast products, and we're looking at California here, as was done earlier, because the California folks, their season sort of already started in a way, and so we've got a first and second generation of these products generated for California. We hope to be switching on Colorado here within the next probably 3 weeks, and so these similar types of products and reports will be generated for Colorado. Essentially, when we go produce reports, we document the differences between running the WRF-Hydro model in what we call an open loop fashion without any ASO data assimilation, and then with the ASO data assimilation in there. And we keep track of a lot of what those differences are. In that middle panel here, you can see a difference plot. This is for the Tuolumne River Basin in California. And you can see a lot of the redistribution of snow according to where ASO has mapped the snowpack. And a lot of times you get a lot of elevational distribution and sometimes also, especially in the melt season, a lot of aspect redistribution of where the snowpack has piled up, where it's been wind loaded and deposited, and where it's ablating very quickly. We keep track of elevational distributions, which is that plot in the upper right-hand corner there. There's tables of basin total snow water equivalent, as well as other variables as well for people who are sort of looking at things in a total catchment sense. We keep track of the time series of all these model states as well. And a new product this year in the lower right-hand corner of that middle panel is the snowpack temperature state, sort of akin to that cold content that Mark reported on, so we can see how ripe the snowpack is, how ready it is for melting. The third panel there is just a snapshot. It's very early in the season, so there's not a lot of accumulated evapotranspiration, which is why that graphic looks fairly benign and it's sort of a general blue shading. As the season wears on, you'll see the differential patterns of evapotranspiration increase as you get into areas that are getting rain versus snow, and then fairly rapid evapotranspiration after that. This does include sublimation fluxes too, so we're really just trying to keep track of what fraction of the water budget is leaving the basin back out through the atmosphere versus that part which is still coming down as stream flow and river flow or reservoir inflow in the model. Next slide, Jeff. These are just some closer up snapshots. This is for the central and southern Sierra Nevada, a bunch of different basins here. Looking at the snowpack analyses and a time series from the Kings River Basin. We keep track in our own graphics display system of the SNODAS product and, like I said, our open loop and ASO assimilated values. And for folks who received our reports last year, you saw some of these same figures. You're going to get a lot of that same content this year and then some more, but hopefully in a much more streamlined fashion. Next slide. This is just one of those difference plots between the open loop model and the ASO assimilated version. And if you look at that sort of big central basin there, that's the San Joaquin Basin, you can see a lot of differences here. The red indicates where the ASO survey was having a lot more snowpack in terms of SWE than the open loop version of the model. So you really do see a pretty significant elevational redistribution and shuffling of the snowpack by the inclusion of the ASO data, which of course has a big impact on melt-off amount, melt-off timing, things like that. Next slide. Graphic of soil moisture, and then the time series plot there is the time series of integrated soil saturation for the basin. And as you can see there, this is California. It's been a relatively warm year. And it's also been a wet year-ish. It's moving towards a wet year with a lot of rain. So their soils have had a pretty steady increase in moisture over the wintertime. And that, of course, can play into how efficiently the snowpack melt runs off in the springtime. So it's another metric we like to keep track of and report on. Next slide. Next slide, Jeff. Okay, and then this is kind of what most folks are interested in. These are the tables of the seasonal water supply forecasts. These are a bunch of the different sites within the Kings River Basin in the Central Sierra. We're looking at a large terminal reservoir at the bottom of the basin, Pine Flat Reservoir, and then there's a number of different internal points. Those internal points can be river flow gauging stations. They can be upstream reservoirs and what have you. The important thing to remember, though, for folks receiving these forecasts is they are all natural flow forecasts. So we're not yet doing any adjustment of these flows to account for withdrawals, diversions, transfers, things like that coming in and out of the basin. So there'll be natural flow forecasts that folks could put into other water management systems. Next slide. And this is just an example of the classic spaghetti plot. We still make these available to folks. We found mixed reception on these. And so we know some people like to see the ensemble spread, which can be very interesting in terms of more risk-based decision-making. But then other folks are just more interested in sort of what the median forecast is, or maybe one of the other couple probabilities. And so all this information is sort of distilled either into those tables or into some simple 2D plots or a spaghetti plot like this. And I think we're getting close to the end, Jeff. Yeah, plans for 24. Yeah, a lot of this has sort of already been talked about or knocked off in terms of what we've been able to do. We are increasing the frequency of the forecast to a regular cadence of every 2 weeks, and then also when an aircraft flight is happening. We have reduced the forecast latency. We're getting that down to just under 24 hours right now, where we were around 48 hours earlier. And so once the sort of the back-end data service is efficiently operating, we're hoping to be turning the forecasts around 24 hours after the survey is made available from the ASO survey retrieval team. And let's see, most of that I've already talked about, and I think that's about it. Yeah, period of performance for Colorado. Again, we start up here next couple of weeks. March 1st, we'll run through September. Our forecast will be focused on April through July or April through October. Different users in Colorado have different needs, and so we try to adjust and provide products for a variety of those. You can see a number of the different sort of product deliverables that we've already talked about: SWE maps, SWE volume, snow melt, ET, soil moisture. And we've got a couple of different ways we're delivering data now. Most of it's going to go out through these forecast reports, but we have started to set up an API for some automated data flow or data pulls. So if people want that, please feel free to reach out. And I think that is it.
That is it. Eric, I'll hand it back to you.
Awesome. Well, thank you, everybody. Really appreciate giving that overview of what ASO is and what those data products look like. So before we move into how stakeholders have been using this data, I want to let you all know where we're going to be collecting this data and where we're going to be doing this forecasting in 2024. So this is what our program's looking like. And when I say we, I really mean a grand royal we, right? We've got just about 35 different funding partners involved in this 2024 program. And that includes federal agencies, state agencies, municipalities, all the way down to ski resorts. There is a wide collection of people who have partaken in this whole process, and they're going to be getting the data this year. So if we take a look at this map here, this light blue area is going to be the snow on data collection for 2024. And these kind of yellowish looking basins here, the yellows and the reds and the oranges, those are all the snow-free data that we either have available or are going to collect in 2024. So there's a lot of area that we can collect this snow on data, but unfortunately didn't have the funding for this particular winter season. And something else I want to point out, we've been talking about this program expanding since 2021. All of this gray area on the map is basically the median May 1st and median April 1st snow-covered area where we could do some snow-free data collection and start collecting snow on data sets should the funding become available. Now, the CWCB board, which we'll get into later, has increased their investment, and we're looking into other avenues to continue funding this as well. We'll get into all of that in more detail, but I wanted to give you all an idea of where we're going to be collecting this data and where these forecasts are going to be taking place in winter of 2024. So with that geographic backdrop fresh in your mind, I'm going to hand it over to Paige Weil, who's going to be running sort of the stakeholder perspective of how this data is being used.
Thanks, Eric. Everybody, fingers crossed that this is going to work the first time with no issues.
Hopefully I took all the pain for everybody.
Right. I think we all need to just work remotely for a while to work out all these kinks, you know, another 5 years maybe. Okay, so over the last few years, the CASM planning team has focused on there's a number of different focuses of our work. A lot of it has to do with funding and governance, and also advancing the snow science and just in general getting ASO deployed. But at the end of the day, the value of this whole program comes from people making better water management decisions by using ASO data. It is Jeff, I was going to say some sort of superlative about ASO, but basically it is the highest resolution Snowpack data set available for sort of the watershed scale that we're working at. And so given that, we feel that the strong working hypothesis of this group is that we can improve streamflow forecasts and improve water management as a result of applying this. So we've asked our stakeholders over the years to help us identify some case studies of where they have used ASO data and it has made a difference in their decision making in a way that using traditional forecasts or index-based forecasts may not have been able to do. So we have several case studies that are kind of in our working library, but there's 3 that we're going to present on today. The first one that I'll talk about is from the Dolores Water Conservancy District, and normally Ken Curtis would talk through this, but he wasn't available today. But we've gone through how the McPhee Dam spilled this year and the Dolores ran for the first time in several years. So we'll talk through that. And then I'm going to have Taylor Winchell from Denver Water talk through how Denver Water used ASO data to optimize their Fraser River collection system efforts in 2023. And then I'll turn it back to Jeff to sort of dig in a little bit more on the comparison between ASO and SNOTEL. We've had a couple of different examples in the last few years where ASO on the same date or at the same basin-wide SNOTEL average for a number of basins, ASO data has shown dramatically different levels of snowpack, and just talking through the implications of that. So I'll just start. And as always with this, I know we're sort of hammering through these slides. If anybody has questions or stuff they want to address, put it in the chat and we'll get to it, or put your hand up, tell us to stop. Yeah, we'll keep going. So this is a brief case study on the 2023 McPhee Dam spill and their use of ASO data for this stakeholder meeting. So in 2023, the Dolores River ran for the first time in several years. It made national news. It made Colorado news if you were a boater, and it made national news because it's such a rare occurrence that the sort of large snowpack in the West was already a big news story, but national outlets like the New York Times, and I think there were a couple other major newspapers that picked up the story that the Dolores River was going to run for the first time in a long time. And that's primarily because even though the Dolores is a significant site for ecology and recreation, the operating rules of the dam and the sort of operating agreements of the dam mean that they're not allowed to make releases for boating unless they can guarantee that the reservoir will fill. Their priority is for their contracted water users and not for the river. Maybe that will change in the future, but for now, the Dolores only runs when there's enough water to fill the dam. So spills are rare. They've only happened 4 times in the last 10 years, and those are often short, typically around Memorial Day. Sometimes they're as short as a week. This year's was quite a bit longer. I didn't actually write down the length, but it was close to 30 days, I believe. And it was incredible. I mean, if anybody paid attention to water news last spring, there were probably half of your friends were out running the Dolores. As we know, 2023 saw record snowpack, and this spill gained national attention. So the bottom right here is sort of the NRCS plot of the basin average SWE for the Dolores, with the 2023 trace highlighted here. So this is a giant messy plot, and I'll walk through it slowly. So ASO flies and Dave and the WRF-Hydro team generate forecasts for the Dolores at Dolores gauge, which is about 90% of the inflow to the McPhee Dam, but it's not the entire thing. But we're focusing entirely on the Dolores at Dolores forecast, just so we can make a fair comparison across all the different data products. On April 1st, which is typically the time that reservoir operators will start making key decisions for how they're going to operate their dams for the year, there was this orange dotted line, which was the remaining capacity in McPhee Dam as of April 1st. So if you can imagine, if there's more than this orange line worth of flow expected to come down, then the reservoir will fill and will spill, and there will be boating opportunities. The purple dots here are the official CBRFC forecasts published by the Colorado Basin River Forecast Center. There's one on March 1st, April 1st, May, and then June 1st. There are some later ones, but I left those off. But the April 1st forecast suggested there was almost a guaranteed spill. So the range, the dots here range from the 10th to 90th percentile of their forecast ensemble. And even the driest conditions showed that McPhee was going to spill. Immediately after that, on April 6th, there was an ASO flight over the Dolores, and resulting ASO SWE measurements were generated here in the red. So this is the measured SWE plus or minus the uncertainty that ASO provides, which of course doesn't account for runoff efficiency. So this is just the total volume of water that sits above this gauge. And then here is the WRF-Hydro forecast that was produced for that gauge on April 13th, the yellow dots. So this forecast is informed by the ASO measured SWE, showing even that full ensemble of forecasts showed that they should have been in the upper portion of the CBRFC's official forecasts. Similarly, the CBRFC produced a series of experimental ASO informed forecasts for us last year as part of their ongoing adoption of ASO and just sort of taking this from research to operations. And their experimental forecast also showed a strong suggestion that we should be in the upper portion of the official forecast. So all this is to say, there were two different corroborations using ASO that the upper portion of the forecast is what should have been considered. And all of this strongly suggested spill and potentially a very large one. Later in the season, you can see there was on May 25th, there was a second flight around what the Dolores folks call their snag or their snow all gone condition, where basically all of their snowtel sites are melted out and they have no vision of what's going to happen. And so this is ASO confirming how much snow was left, even though their traditional source of information was blind. And that further confirmed the total runoff for the year. So this black dotted line is the actual outcome for the season. So this is the total amount of flow that came down by the Dolores at Dolores gauge. And then this blue is just cumulative day by day. So early flight and resulting forecasts strongly suggested they were on the high end of the official forecast. And later on in the season, they further suggested that they were at the high end of that forecast. So even the June 1st CBRFC forecast had a much larger spread than both the experimental and the WRF-Hydro ASO informed forecasts. So in general, the Dolores folks used ASO. They planned this so that they could make an early decision as runoff was about to start, and then a late decision as their snow all gone condition was reached about how to operate their reservoir. And based on this data, it strongly suggests that they, this was a valuable tool. Now, they will point out, and I'll go to the next slide to talk about how this sort of happened. They did not have sufficient manpower at the conservation district or at the Conservancy district to maximize the use of that excess water. They did spill. They probably could have extended that spill a little bit farther had they had kind of manpower and the right optimization tools to make that happen. But I think everybody was pretty happy with the spill they got, so it's not the worst thing. Partially, the spill that they were going to make was delayed because of downstream tributary inflows on the San Miguel River, which is another lower tributary to the Dolores. But just walking through what this plot shows, so the red dotted line are McPhee contents. The orange dotted line at the top is the maximum McPhee contents, and when it will start to, when it's forced to spill. The blue solid line are the total observed inflows, and then the black solid line are the releases made from McPhee. And then this purple line is just what those downstream inflows look like. So you can see what happened at this first flight. They had to wait to actually make releases here because there were significant tributary inflows that they didn't want to exacerbate downstream flooding by adding more water to the system. So they were asked to delay their release. But then after May 26th, in this snow all gone condition, they had to make a decision about how much more to spill and how to taper off this spill, knowing that their main requirement is to fill the reservoir. So with the right manpower, they could have extended the spill a little bit farther rather than being forced to release when the reservoir hit its peak. So I think in general, it was a valuable tool. I think the Dolores folks have seen the value of ASO through this last very wet season, and especially kind of capturing the bookends of the runoff season, peak SWE and snow all gone, help them and could help them in the future optimize their spill. So that's what I have on this. Does anybody have any questions or comments about how this went? I can answer some of them. I don't work at the Dolores Conservancy District, but I'm happy to help. So a few lessons learned from this. I've talked through most of these already, but ASO could have been used in the following ways. They could have optimized and extended the spill and that boating season with kind of the right tools at their disposal to actually use it with their reservoir with their reservoir plans. They had a goal of targeting and understanding basin runoff efficiencies as well. I think they didn't have the resources to actually do that this year, but that's a goal of theirs. In the future, they'd like to extend ASO flights if possible over the full drainage of McPhee Reservoir. There's one of the things that happened early season over the Dolores was the part of the basin that is not tributary to the Dolores at Dolores gauge. They call their low snow, which is their region from 7,000 to 9,000 feet elevation, that had significant snowpack at peak SWE in a way that it doesn't typically, and it's also not monitored by SNOTEL sites. So an early ASO flight would have helped them capture that a little bit better. And then also using ASO, WRF-Hydro, and the CBRFC's experimental forecast to help drive selection of the part of the official forecast ensemble as they're doing their decision making. So still relying on the official product that they're required to use, or that's legally defensible for them to use, but focusing on a portion of that ensemble rather than just rolling the dice about the whole range of it. So that's all I have on McPhee. So Taylor, if you're here, do you want to take over and talk about the Fraser River? So question from Mark Raleigh. An example of the Dolores, the official CBRFC forecast without ASO was pretty decent. So yeah, I mean, if you look at this set of purple dots here, this is the official CBRFC forecast on April 1st, and there was basically a guaranteed spill. The 10th percentile of the forecast ensemble was dramatically higher than what needed to flow into the reservoir to make it spill. The trick is around just how they could have extended that spill by having a better understanding of their remaining snowpack. So if you look at this operating plan here, they could have potentially released a little bit less here and then extended their total spill out farther, or maybe even dropped their spill a little bit lower and kept it lower for longer just to keep the river running. So yes, this was a very wet year, so this is one of those great examples that we all like to see. Wouldn't it be nice if ASO caused record snowpack years every time it was flown? So Taylor, if you can do it, it's
Yeah, I'm just loading up my slides here. Should be coming up. All right, I've lost visual of my browser and the chat and whatnot. So if anyone has a question or anything, just unmute and let me know, or if you put it in the chat, if someone could read that off for me. So yeah, hi everybody, Taylor Winchell from Denver Water, and I am filling in today to present on this for Nathan Elder, who is our raw water operations manager. So he's the one who most directly utilizes the ASO data to make the operational raw water decisions. He got pulled into a training today, so I'm presenting on behalf of him, but just going to talk through our application of ASO in the Fraser River collection system in 2023, and how we were able to optimize water that we could leave in the river while meeting our diversion needs. So just give a quick overview to orient us here of the Denver water collection system. So here's our service area down here outlined in red. And then we have collection basins on both sides of the Continental Divide here. So here's the Upper South Platte watershed. Here's the Upper Blue, which feeds into Dillon Reservoir. Then we have the Roberts Tunnel, which brings water from Dillon Reservoir into the North Fork of the Upper South Platte. And then this orange portion here is our collection system area in the Upper Fraser. And that area has the Moffett Tunnel, which brings that diverted water from the Upper Fraser into South Boulder Creek. And one notable thing here is that there is no major reservoir to capture water from this Upper Fraser system. And you'll see on the next slide how that makes operation of that system quite complex. So this is the Fraser River collection system, zoomed in a little bit. And within this system, there are about 34 miles of canals, pipes, and tunnels, 30 diversions, which are marked by those red triangles there, and then 6 sub-watersheds within this Upper Fraser system. And those 30 diversion points are manually operated. So they, if you want to divert water from the system, basically you have to operate those diversion points to get water into this canal system that then feeds into the Moffett Tunnel, which is right here to bring it over to that South Boulder Creek watershed. And so there's lots of variation amongst these sub-watersheds and amongst the water going into each diversion point. So it's a challenge each year to know and to have confident information as to how to operate each individual diversion point. And so generally what that ends up meaning is that at the start of the diversion season, we'll just basically start diverting water at each one of these 30 points in order to fill our diversion needs, and then kind of adjust as the season goes on. But it's a pretty kind of loose method that's course method. And the reason for it is because we don't have enough granular information to make individual decisions on each one of these diversion points. And this kind of points to that a bit. So this is just some of the information we have in this watershed here. So 3 SNOTEL sites. This is the Berthoud Pass one, which is right on the watershed boundary here with Clear Creek. And that is a fairly robust record. It goes back pretty far in time. I forgot the exact year, but it's certainly more than 30 years. And then the Elk Creek, I forgot the name of these 2 specifically, but they're much shorter records. I think they started around 2011. And And then there is a CBRFC forecast point here for the Fraser River, but that really covers the flow directly down from just this subwatershed above that. And it doesn't cover the entire 6 subwatersheds. And so we don't have beyond that much information for, how much natural flow to expect in the additional subwatersheds throughout the basin. And if, there's been efforts to try to make some relationships between that natural flow at this point, the Fraser River at Winter Park, and say, so this is like with the Little Vasquez Creek, which is here, as you can see, and you just get a really poor relationship. So the natural flow that comes at this forecasted point doesn't necessarily translate directly to the rest of the watershed. So again, that points to, how difficult it is to make individual decisions at these 30 diversion points. And then another important thing to note here for this example is that if you look at where these tributaries hit or have a confluence with the Fraser River, so if you follow my mouse here, this line is the Fraser River. Then of course the Fraser River meets up with the Colorado. So these subwatersheds come in. So this direction here is south, further south on the Fraser River. And then these subwatersheds here really come in around Tabernash up here, and they skip this whole part of the river. And so what we were able to do with the ASO data from 2023 is it was split up into those 6 subwatersheds and calculated across the watersheds. And it was kind of a unique year because we were getting quite a bit of rain then on the east side of the divide there in the South Boulder Creek watershed. And that meant a couple things. It meant our demands were lower. And it also meant that we were able to tap into some of our water rights, direct flow, or to some of our water rights on South Boulder Creek, which are more junior water rights. But in years when there's more, particularly rain in the system, we're able to tap into those. So it meant we needed less water diverted from this Fraser system. So then the question becomes, well, if we need less water overall from the system, where do we choose to make those diversions? And in previous years, again, we might have just taken that approach of just start diverting everywhere and then close them off as we start to meet our diversions. But what we were able to do with the ASO data from last year is confirm that in this blue Ranch Creek watershed, there was enough snow up there to where if we just diverted from the diversion points within this subwatershed, we'd be able to meet our needs of water diverted from this entire watershed for 2023. And having that data allowed us the confidence to make that decision that, okay, we'd only need to divert right there. And then what that allowed us to do is bypass the water in these subwatersheds over here from those diversion points. And so all that water stayed in the river. And then, as you recall, those subwatersheds are the ones that go through this stretch between Winter Park, Fraser, and Tabernash. And so all that water was able to boost the Fraser River then in that stretch there. And we were also able to not divert from this Meadow Creek watershed and let all the flow go through there. And that allowed us to achieve what we call a flushing flow, which we try to have kind of a flushing flow of that river system when we can. And the target for that watershed is 50 CFS, which is pretty hard to hit. And we were able to hit it in that watershed, and we try to do that when we can. So it allowed us, again, to just pinpoint where we were diverting water from because we had that more granular information of how much snow by volume was in that sub watershed. So that's really the example here. And I think the last slide there is just how, ASO and this background here, that is the Upper Fraser watershed, provides us with that operational certainty, flexibility, and then additional benefits to the river there. As I mentioned, that water was able to keep the river at higher levels in that stretch of, upstream of Tabernash as a result of the operation. So that's what I have for today. Yeah, happy to take questions if there are any. Seems like not. So yeah, I'll pass it back to Eric, I believe.
So it's to me, but then Jeff is going to talk about the ASO SNOTEL site comparison.
Yeah, that's right.
All right, here we go. I'll actually expand a little more than just SNOTEL stuff, but a few good examples of some data comparisons and usage. So first off, this is the Blue River in Summit County from last year, 2023, flight on in early April, and then the second flight later in May, showing the melt off and the remaining snow there. Our second flight was a little over midway through the snow melt according to the 4 SNOTEL stations in the basin. And just by way of reference timing there, here's what the distribution of snow looked like by elevation on the 2 flights there in the top left. So maybe a slight increase at the upper elevations going into the late May flight, but strong melt out, of course, at most other elevations below, say about 12.5. And represented graphically for the May flight in the blue radial plot, and then the change between the two, showing that slight increase at the upper elevation north-facing terrain on the right radial plot. Of interest in comparison to the prior year, so April 19th, 2022 was our first ASO flight that year, and April 16th, 2023 was the flight this past water year. On those 2 dates, the SNOTEL SWE average for the 4 stations in the basin was basically the same thing, if anything, shading towards a slightly higher snowpack in 2022. The ASO SWE volume measurement, however, on those 2 dates showed about 20% more water in 2023 than in 2022, which is key information. Again, I think highlighting that the combination of these 2 measurement types really provides both the spatial and temporal capturing of the snowpack dynamics that's really useful for Nathan and crew running the dam down there. So interesting result there. At the same time, so same data set at the top left of this screen. This is showing both the Blue River and the Upper South Platte flown on the same day, April 16th. The divide highlighted by the white dash line through the middle there. And just a really interesting contrast in snowpacks on both sides of the divide, with the smaller area of the Blue River having not quite double, but close to double the snowpack in total volume that the Upper South Platte area did. And that Upper South Platte zone includes the upper middle fork there above Bailey. And that's shown graphically, thanks Taylor for the bar graph showing the 2 basins by elevation band there. So really, I think giving us a lot more window into the dramatically different snowpacks just in close proximity to each other on both sides of the divide. The number of years we've been flying in the Upper Gunnison allows us to look at several years in comparison. A natural thing for us to do as humans is compare current conditions to what we've experienced in the past. And so last year with the big snowpack, it was natural to think about the last big year we had, which was 2019. And so the next 2 slides, this shows a comparison between the 2023 snowpack measured on April 1st compared to the April 7th flight in 2019 for the same domains. In this case, for the East River, looking at the SNOTEL traces, both years well above the median trace, pretty astonishingly so, honestly, but pretty close in value. Not showing much difference on the snow tells. This is a combination of Schofield Pass and Butte snow tell locations, and about 5% more SWE actually in 2019 than in 2023. Which, you know, that's a significant amount, but really is what is interesting to me is the pattern change in those between those 2 years on similar dates, and that's what the map is showing. So plus or minus a half meter or greater at the extremes of the blue and red colors there. And there's a couple different patterns going on here. One of them fascinating to me is we can really see the extent of the massive avalanche cycle that happened in March of 2019. So the really dark blue areas on the western edge of the basin, those are areas where snow existed on the hill slopes in 2023, but did not in 2019, or very little. And that's all of the avalanche release zones and tracks. And you can see in close proximity some really dark red areas, and that's where the debris piles from those avalanches existed in 2019, but did not in 2023. So that pattern is actually pretty widespread throughout this domain. Superimposed on that, we can see some changes in the wind redistribution pattern that shows up as kind of the speckle. It's especially noteworthy in the northeast part of the basin. And then some larger scale patterns, we see the blue in the valley bottoms is showing that there's more snow on the valley floors in 2023 than there was in 2019. And the inverse on the montane hill slopes and subalpine hill slopes in the forest, with more snow in 2019 than 2023. Even if it was exactly the same amount of SWE in both years, those differences in pattern portend different melt out, different timing of snow melt runoff between those 2 years, the spatial distribution being pretty key. So again, highlighting the combined information value here. Just across into the Upper Taylor River, so same flight dates. If you look at the SNOTEL graph showing Upper Taylor and Park Cone in SNOTELs in this basin, the SNOTELs were suggesting that 2019 had a good bit more SWE in the basin than did 2023. The ASO SWE volumes above Taylor Park Reservoir in both years were exactly the same at 207,000 acre feet. And the spatial pattern is of slightly lower magnitude overall, but still showing the same patterns of difference that we saw just over the hill in the East River. So kind of a couple interesting highlights there of the added information that the spatial ASO products can bring to the table. I've showed this example a number of times, but I think it really highlights a couple different benefits that the ASO program can add as we adapt to changing snowpacks, changing temperatures and precipitation, and changing watershed conditions from impacts like wildfire. This is the Feather River Basin in Northern California from a couple years ago, 2022. 60% of that watershed has burned over the past, the prior 4 years. So big changes in the basin forest cover, and therefore the basin hydrology. And we're seeing some analogs to that in some Colorado watersheds as well. In 2022, almost a harbinger of what we might expect from climate change influenced hydrology, the snowpack in California in 2022 peaked on January 1st, which is sort of horrifying to think about. And the conventional snow water equivalent products were strongly overestimating SWE volume. We flew in mid-February and came back showing about half the amount of snowpack that was expected by other metrics in the basin. Not really good news. We didn't show up with more snow, but at least that's some early warning for the operators of the California Water Project to convey to their stakeholders. We flew again a couple times in March, and saw half of that meager snowpack disappear during the month of March, which was also unexpected. And when we look closer at it, we really were able to see the impacts of soot coming off of the standing burned dead tree stems, landing on the snow cover and reducing its snow albedo, and enhancing snow melt, in some cases doubling the amount of solar energy going in. And we could see that in our spectrometer data, where areas that were affected by soot were a lot darker than areas where the counterintuitively, perhaps the burn was more intense and all of the tree stems were laid down under the snowpack. So really looking at this as kind of a combined response to two different forcings that are messing with our hydrology, the changing in our climate parameters and changes in watershed condition, that ASO can contribute some novel information to help manage. Another thing I want to look at, this gets at a little bit of what Paige was talking about in the Dolores, and Mark Raleigh brought to the fore, and I want to tip the cap to Cody Mosier at CVRFC for some of these graphics and analysis. With a number of years of ASO data, and we're able to start evaluating how we are able to represent the snowpack through conventional methods and through what ASO can bring to the table. An example here from 2023 and 2021 in the Roaring Fork, the middle of these forecast plots from the River Forecast Center is the April 1st forecast. 2023, as was widely the case across the board, the River Forecast Center was pretty spot on with the April through July runoff forecast, fairly early in the season, starting April 1st. And if we look at the distribution of the ASO SWE versus the River Forecast Center SWE in their different forecast polygons, we can see in the bottom plot there that they agreed pretty well at most snow depths. So basically, the River Forecast Center SWE was doing a really good job of representing the actual SWE in the watersheds last year, and we see commensurately good forecast performance pretty early. By contrast, in 2021, a year that's commonly pointed to as where did all the snow go? We see that the RFC SWE was overestimating the amount of water equivalent in the watersheds writ large. I should point out that these scatter plots are actually for the full state of Colorado, not just the Roaring Fork. I'm just showing the Roaring Fork flow forecasts for simplicity here. But largely the RFC SWE, which is built from SNOTEL precipitation observations, was generally saying more SWE than actually was up there. And the forecasts, I believe, represented that with even the 10% exceedance being too high compared to the ultimate observed flow there. So I think really highlighting the importance of getting the snowpack right going into the melt season. Of course, that doesn't eliminate the contributions from uncertainty in future weather. That's always going to be the case, but starting from the right snowpack, like existed in 2023, really helps get that forecast accuracy better earlier, which is a great thing. So thanks again, Cody, for looking into the SWE comparisons there. And I think I will stop there for the sake of time.
Jeff, there was a question from, I believe that's Dave Kanzer, who's Yo Dave on the chat there, but he asked, the 2023 runoff for the Roaring Fork Basin seemed low. Is that observed or native?
Good question. I didn't actually look at the number. I just pulled the graphics from the website there. Let's see, about 800,000 acre feet. I'll connect with you offline, Dave.
All right. Well, thank you all for that perspective on how the data has been used. So I'm going to wrap things up today by talking about where the program is headed moving forward, and then how you all as stakeholders can get involved. So just to kick things off, the big question that's been going through the CASM planning team is whether or not CASM could become a full-fledged CWCB program. The CASM planning team members did recently submit a purpose and need white paper to CWCB leadership that sort of explains the need for CWCB ownership of this program. That's things like funding stability, administrative capacity, stuff like that. You know, right now we've been running this program really in a piecemeal kind of approach. Every year's been a scramble to get all the funding together. It's taken a lot of time on behalf of the planning team volunteers, on behalf of ASO and CWCB staff. So trying to find a more centralized way to run this program is top of mind for CASM at the moment. CWCB is currently having internal discussions of what that would look like if and how a CASM program could be incorporated into CWCB. So stay tuned for more information on that. Unfortunately, I don't have more to provide to you all at this meeting, but I wanted to let you know those conversations are happening at the CWCB internal level. One thing I do want to reiterate is that this is still always going to be a stakeholder-driven process. I think that that is one of the key parts of the success of this program is having you all involved and having a planning team of people from around the state providing their input. You know, even with the flight timing itself, there's a flight coordination committee where the folks who have put up the money for these flights get to talk to ASO themselves to coordinate the flights. That is not a CWCB decision item. So I want to reiterate that if this were to become a CWCB program, it would still very much be a stakeholder-driven process. So just want to throw that out there. Another thing to talk about moving forward is the funding. When I pulled up that map, I mentioned that right now we have around 35 funding partners. That is a lot. And a lot of those folks don't have the budgetary bandwidth to make that year-to-year contribution. And right now, CWCB's board is very much in favor of this program. And so the board has increased their investment through the projects bill to $2 million. The bill, I don't believe, has been introduced just yet, but if everything goes through according to plan, that $2 million will be available for next winter for the fiscal year 2024-2025. So CWCB is very on board with this program. We've increased our investments. There is potential for continued UCRC investment. So this year, we were lucky enough to get $800,000 from the Upper Colorado River Commission. That has been put towards the Dolores, the Easton Taylor Basins, and the Yampa, which is a brand new snow on flight for us, which is pretty cool. So UCRC does have funding available for that. However, other upper basin states are going to be more involved in ASO work moving forward. I know Utah is spinning up a program. I know New Mexico is interested. I haven't heard anything from Wyoming, but that funding from UCRC might be spread a little more thin next year. So I just want to make folks aware of that as well. Something else is the Bureau of Reclamation Snow Water Supply Forecasting Notice of Funding Opportunity. That is a giant mouthful, so we like to call it SNOFO. Last year, we had one grant application that was successful. That was Northern Water. So all of their flights this year are being funded primarily through Bureau of Reclamation with some match from Northern and CWCB, but primarily through the Bureau. So we're keeping our eye out for that to be posted this year. It's supposed to be posted this month. However, the month ends next week. So whether or not that actually occurs is still kind of up in the air. But that is right now what the future of this program is looking like. So with that, how can you all get involved? Well, first and foremost, we do have a website. So if you go to coloradosnow.org, you can sign up for our newsletter. That's where you'll get all of the information on when these flights are happening, when the data is available. You'll be getting newsletters. You'll be getting all this information directly to your email. So sign up for that newsletter. We're also going to have a little questionnaire that's going to be coming out of how you all are going to use ASO data if you're currently using it, or how you would want to use it if you want to use it in the future. So keep an eye on your emails for that. Now, another big important piece of how you can get involved is ground truthing all of this data. I mentioned the Flight Coordination Committee a little bit. So that's a group of all the folks who are receiving these flights and funding these flights. They coordinate with ASO in order to figure out when the timing is going to be best. but we need folks to actually go out on the ground and take depth and snow water equivalent measurements. So if you are interested in volunteering for that, please let one of us know at the contacts below so that we can make sure that you know when those flights are occurring. Because correct me if I'm wrong, Jeff, but those ground truthing efforts have to occur within a day, if not on the day of the actual flights.
Yeah, closer the better. And there's a few things that we need to make them most useful. So it'd be great to coordinate that ahead of time so we can get all the ducks in a row.
Yep. So reach out to Jeff if you're interested in ground truthing. His email's down at the bottom there. I also wanted to give a shout out to a NASA community science program called the Community Snow Observations. So we're going to explore how we can best utilize that data in this program, if at all. But it would also be awesome if while you're out there collecting data for the CASM program, if you'd submit that to communitysnowobs.org as well. Just the more data we have in all these different programs, the better off we're all going to be when it comes to understanding our snowpack and stream flows. So we have this large stakeholder meeting today, but coming to a basin near you, we also have some more localized workshops. Coming up on March 12th, we have a workshop for the Upper South Platte that's going to be hosted by Taylor Winchell. His email's there. Reach out to him if you want more information on that. And there's also going to be a Front Range CASM workshop. The date on that is to be determined. We did have to reschedule, so we're figuring that out right now. Reach out to Scott Griebling for more information there. And just to reiterate, if at any point you have any questions about how you can get involved, if your basin isn't receiving some data and you would like to explore options of getting data in your basin, reach out to us. You know, I've got my email there, Paige's email is there, and Jeff's email is there as well. So that is the end of everything that we had for you today. I know that we threw a ton of information at you. So I really appreciate everyone's time today and everyone's involvement in this program. I've said it before and I'll say it again. This would not be as incredible of a program as it is without all of your input and involvement. So I really can't thank you enough. So with that, we'll open it up for questions. Scott Griebling, you had your hand up first, and then we'll go to Matt Spartacino, I think.
Yeah, Eric, I just want to let you know, it looks like March 5th at 10 a.m. is the date for the North Front Range workshop. So I'll be circulating that to all the North Front Range folks.
March 5th at 10 a.m. All right.
If you're interested, can reach out to me.
Breaking news. You heard it here first, folks. All right, Matt, you're up.
Yeah, thanks, everyone. So Greeley is most interested in the Pooter. And throughout these conversations last year, I know we were talking about 2 flights in the Pooter, and for a variety of reasons, and mostly including weather, we only had 1 flight last year. It was pretty late. I think it was May 22nd. So I spotted on the planning schedule for this year that there's only 1 Front Range flight plan. So I'm wondering why that decision was made. I think we were told that that second Pooter Front Range flight would be bumped to this year.
Yeah, I can take that, Matt. Thanks for asking. The second flight, because we had applied for that Bureau of Rec grant, and because we didn't get that grant, we're using all of the money from last year's flights to go towards 1 flight this year. So we we didn't have enough funds for 2 flights is what it comes down to.
Thanks, Scott.
Yeah, unfortunately, it's definitely a lesson, and we can only have as much fun as we can afford. So with that, any other questions? All right, seeing none. Any comments from the CASM planning team before we call it a day?
So data will start to become available and filter out here as flights happen in April. We're going to try and host a lot of that. Yeah, I think a lot of that we'll do some internal coordination to make sure that everybody gets the data they're expecting when they expect to get it. There will also be updates posted to our program website, coloradosnow.org. So keep an eye on that. We try to limit the number of email blasts you send. So we will probably we'll probably send around once a month, just updates of where we're at throughout the runoff season. But otherwise, you can always check back to the site for the latest info.
Thanks, Paige.
And Eric, have we started scheduling any of the flight coordination meetings yet?
Nope, not yet. But
Okay.
I'll be reaching out to the folks that are getting flights this year to start spinning up that effort very soon. All right. Well, thank you again, everyone, for your time this afternoon. Really appreciate it. If you have any additional questions, please reach out to us, really. Like I said, this process wouldn't be the same without your input. So let us know what you're thinking and how we can better serve you. So thanks again, and have a great rest of your week.
Thanks,
Good
Eric.
job, Eric. Thank you.
Thank you.